Okay, so I guess I need to finish. What you were supposed to do for today for the review session was to print and take this as if it were a real test, and then come today prepared with your questions over it. So we don't have time to do every question, so we'll do the ones that are confusing to you, and then there. And then after that, I will post the key to this that has all the answers on it. Right? Now that doesn't necessarily mean you still understand it. So sometimes, particularly multiple choice and questions like that, you say, oh, the answer is A, but there's no explanation why it's A. So then email me to get those kind of things answered. All right? So where do you want to start? Nobody has a question? All right, we'll see you Monday. Number 7, okay. I kind of anticipated this might be the first question asked. It's one of the harder ones on there, I think. In human engineering and product design, it is important to consider weights of people so that airplanes or elevators aren't overloaded. Based on data, blah, 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 the weight of adult males follows a bell-shaped distribution with a mean weight of 173 and a standard deviation of 30. Ooh, bell-shaped distribution. Then they ask about proportion of weights between 203 and 263. First thing you need to get good at doing is being able to read a big, nasty paragraph like that and figure out, okay, what kind of question do I got here? What's the strategy to attack this problem? Well, the first thing you should do is look at the question they're asking. What proportion of weights is between 203 and 263? What have we done that tells us proportions between values under a bell-shaped curve? What'd you say? Yeah, we talked about quartiles a little bit. That's not what we're after. I heard somebody else. Empirical rule. That's right. So if this thing is bell-shaped and symmetric, where's the mean in a bell-shaped distribution? Right in the middle. So the mean, it tells us, is 173 pounds. And then how far out do you go to get one standard deviation? In the picture. Where would I mark it?
Halfway down the hill.
Halfway down the hill. Good. So halfway down the hill, in either direction, is one standard deviation, and they tell us the standard deviation is 30 pounds. So I add 30 to 173, and I get 203. Oh, there's a clue that they happen to use that exact number, 203. Right? So empirical rule problems will always be some multiples of the mean plus or minus standard deviation. Right? So then on this side is 143, and then 263. Well, if I go one more standard deviation, I'm out to 233. And so I have to go to the third standard deviation to get to 263. Right? So you draw a picture and then shade the region you're supposed to find the probability for, or the proportion for. When we get to chapter 5, we'll call it probability. Same thing. So I'm shading this region right here, and it stops at 263. Right? Now the empirical rule doesn't tell us area in the tail, it tells us area in the middle. So between the two dotted lines is what percent of the population? 68%. Or the answers here are in proportions, and that's what they ask, so that's the same thing as 0.68. Right? Now, if this didn't stop at 263, and it went all the way to infinity, what percent would be in this tail? What'd you say? 16. Where'd you get 16?
I did 100% minus 68.
Okay.
That's 32, and divide by 2.
Very good. She did 100 minus 68. That's 32, which is the area not in between the dotted lines. So then half of that area is up here in the upper tail, half of that area is down here. So it's, I would say, half the leftover percent. So half the leftover percent is 16 from here all the way to infinity. Or actually, let me use 0.16. So already, you can probably pick which of these is the right answer. Now notice that one, 0.16, is one of the options. Is that correct? No. Why not? Because there's this tiny sliver of area out past there that is not shaded. Right? We have to stop at 263. So I need a number that's just a little bit less than 0.16, and there's only one of those. But the one you get on the test might not be multiple choice. So you need to still come up with that exact answer. So now what do I need to do? I got 0.16 all the way to infinity. I need to subtract off this area. How do I find that area? Good. Exactly the same way we found that percent. The area in a tail out past a certain number of standard deviations is just half the leftover percent from what the empirical rule says. So this is 3 standard deviations out there. So in between, mu plus or minus 3 sigma is what percent of the population? This is the empirical rule, which, by the way, should be on your cheat sheet. Right? What's that percent? 99.7. So I'm going to write it as a proportion, 0.997. So I need half the leftover proportion, and that's the area in that tiny sliver of a tail. So the leftover proportion is 1 minus 0.997, which is 0.003. Half of that is 0.0015. Now we subtract that off of the 16. So 0.16 minus 0.0015 is 0.1585. So option A. Okay? Looks really easy when someone else is doing it, doesn't it? So practice. Practice, you know, ask yourself a question. Well, what if they had asked me from negative infinity up to this one, or something like that, right? You get just subtraction and addition to figure it out. Now, the book sometimes starts with the middle and says, well, above 173 would be 0.5. It's half of the area. And then they start subtracting off pieces. And so you can get it other ways. Okay, next question. What? 17. You're jumping a long ways down. Anybody need one in between there? Not that I can't go backward. Okay, 17 says, determine which of the 4 types of data, and then gives you the 4 choices, categorical, ordinal, and so on, is most appropriate for each of these. So the first one, part A, says the academic major of each student at Washburn. Is that numerical data or qualitative data? That's qualitative or categorical, right? So that first one is categorical. Second one, number of classes being taken by each student at Washburn. Number of classes, that's numerical, right? So now you have to decide, oh, is it continuous or is it discrete? It's discrete. Why is it discrete? Remember what discrete means. It means there's gaps in between values. It can only take on certain values, and usually it's whole numbers only. And that's the case here. Count data is always discrete. So if you're counting how many of something, it'll be discrete data. GPA of each student at Washburn, that's continuous, because that can have decimals, and it can have, theoretically, an unlimited number of decimals. You could have a GPA of 3.333333 repeating, right? So that's continuous, quantitative. And then D, the class designations of freshman, sophomore, junior, senior. Those are just categories, but there is a natural order to them. So ordered categories is ordinal. So that's ordinal data. Okay, next question.
$19.
19? All right. I don't know how much of this I can show at one time, so I'll read the top part and then I'll scroll down so we can see the picture. It says, the paper Acid Rain Controversy, blah, 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 gave the following frequency histogram on sulfur dioxide emission rates. Okay, so then describe the shape of the distribution. So part A is just an interpretation thing. Describe the shape of that distribution. Right skewed. Right, it's right skewed. It's got a hump, so it's a little bit of a bell, but the right tail is a lot longer than the left tail. Right, so that's right skewed. B says, what information can you get from the dot plot or stem and leaf plot of these data that you cannot get from this plot? Not necessarily just the outliers, but the original data. You get all the data points. So yeah, you get the outliers, but you also get all the other data points. Here, for instance, I can't tell you the states. I can see that there's 5 states that were between 0 and 0.5, but I don't know if that's 0.1, 0.2, 0.38, right? I don't know the original data from a histogram. All right, part C. What percent of the 47 states were above 3.0? What percent were above 3.0? Well, this is a frequency histogram. What does that mean? That means these are counts or frequencies. They're not percentages. So I got to get the counts and then turn it into a percentage. So just looking at the heights of these bars, this isn't labeled very good, but you can kind of tell that if this is 5, then halfway would be 2.5. So that one must be 3. This one must be 1. Right? So I've got, move that up. This must be a 1, a 3, a 1, and a 1. Right? So that's a total of 6 that are above 3.0. So 6 out of how many? 47 states. Convert that to a percent. What do you get? Take 6, divide by by 47, and then move the decimal 2 places. 12.8. Okay. D says the histogram shows the frequencies. If you were to construct a histogram using the percentages, how, if at all, would the shape of the histogram change? So if I make it, instead of a frequency histogram, I make it a percent histogram, how would that change the shape of it? Rachel? Yeah, you went, and then
No,
you got, maybe you're right, it wouldn't change. The only thing that changes is the scale on the y-axis. That's why you could do either one you want. because it doesn't affect how it looks. All right, next question. You guys are taking too long to get your questions out. We're going to run out of time. The quicker you fire these off, the quicker we can get, the more we can get through.
23.
23, what'd you say? 12? Okay. Remind me to come back to 23. We'll go up and do 12 first. Low bid always wins. 12 says, according to the empirical rule, approximately 95% of the data from a bell-shaped distribution fall within 2 standard deviations of the mean. Right? So you may have been confused thinking, well, I don't know the numbers here. You don't, this is just, it's always 2 standard deviations no matter what that turns out to be. Okay? And then 23. So 23 says the supermarket selected a sample of 250 customers, measured how long it took them to be served at the checkout counter. If too many customers wait too long, they intend to hire more checkout personnel. So they would like at least 82% of customers to be checked out in 8.2 minutes or less. Now I'll just tell you, I went into the Hawks Learning System homework and copied this question. You may recognize it, right? And so that the numbers are just generous, so they're weird. You know, the company wouldn't use 82%; they would use 80. It's some nice round number, but 82% to be checked out in 8.2 minutes or less. From the data, the 90th and 60th percentiles were computed to be 10 minutes and 6.6 minutes, respectively. The range of the data was 14 minutes, and the fastest was checked out in 1.2 minutes. Now remember what I said a few times this semester? Don't panic when you read a big long paragraph full of numbers, and because you read that and you're like, I have no idea what that just said. But then just go back to the beginning and start writing down what they give you. Right? They selected a sample of 250. N equal 250. I don't know that I'll need that number, but I might. So N equal 250. Then specifically, they would like at least 82% to be checked out in 8.2 minutes or less. If 82% are 8.2 minutes or less, that 8.2 minutes would be the what? The 82nd percentile. So what they want is P82 to be 8.2. Then they start giving us values. The 90th percentile is 10 minutes. So they give us that P90 is 10 and P60 is 6.6. The range of the data is 14 minutes. The fastest was 1.2. The fastest, what is that number? That's the min, right? So they tell us that the min is 1.2 and the range is 14. From the range, we can get the max. So what would the max be? Max equals 1.2 plus the range, right? So 15.2. All right, so what is the longest time? That's part A. So we just did that. The max would be 15.2. Everybody understand how I got that? B says, based on the given information, determine if the following statement is true or false. The median of the data exceeds 2.6 or 6.6. The median exceeds 6.6. I heard false. And then I heard a lot of silence. False is correct. How do you know it's false?
The 6.6 is the 60th percentile.
That's the 60th percentile. The median is the 50th percentile, and it has to be less than that, right? Actually, it has to be less than or equal to that. If you had a whole bunch of ties, it's possible that the 50th percentile and the 60th percentile are the same number, but it certainly can't be greater than the 60th percentile. So that's a false statement. Approximately how many customers waited 60 minutes or less? How many customers? Oh, I know what you were doing. Good. I was thinking, well, duh, the answer is 60%, but they didn't ask what percent of customers, they asked how many customers. So you need to change that 60% into count, so I am going to need that in. So 60% of 250 multiplied by 0.6, and you get, what'd you say? 150. Now, why does it say approximately instead of exactly? Yeah, that could be it. That you had to round to 150, so you can't have a half a person or whatever. There's another reason that it might only be approximately. I said you can have ties in the data, right? So this 6.6 might also be the 61st percentile and the 62nd percentile if there's a lot more ties. So it's around 60%, less than that, but it might not be exactly 60%. Okay, last part. What percentage of the customers were checked out between 6.6 and 10? 30%. So 90% were 10 or less. 60% were 6.6 or less. So subtract the two and you get 30% that were in between the two. And again, it's approximately. Although they didn't use that word, but because the 6.6 may be higher percentiles than just that. All right, next question. 15? Oh, 8. Okay, 18 talks about reduce pollutants from motor vehicle exhaust emissions, blah, 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 that converts. And a study was done, and it came up with these numbers. So 150, 1.53, 1.5, and so on. A says, find the mean, standard deviation, and 5-number summary of this data. What's your strategy there? Put it in your calculator.
I should know what the IQR was.
IQR stands for interquartile range. So, and tell us what that is, somebody. Q3 minus Q1. So IQR is Q3 minus Q1. Remember, there's 3 quartiles. The first quartile, the second quartile, which is also the median, and the third quartile. The distance between the third quartile and the first quartile is called the interquartile range. And it's a measure of what? What? No? Spread. It's a measure of spread. How much variability is there in this data? How spread out are the numbers? Right? The distance between 2 of the numbers tells you spread. So you're going to take these numbers and you're going to put them into a list. Say L1 in your calculator, and then do what? What do you do once you have the data in a list? Where do you go to get mean, standard deviation, 5-number summary, all those things, all in one shot? One var stats. So you go stat button, calc, and then one var stats. And then tell it what list you put it in. Right? So by default, if you used L1, you don't have to tell it. That's the one it'll use if you don't give it one. But that's a dangerous habit to be in. I like to tell it even if it's L1, just so I'm always in the habit of making sure I've analyze the correct data. Yeah.
On the test, are you gonna want us to use like the rounding rule, like 4 decimal places, or are you gonna tell us specifically? Like,
If I think of it, I will tell you. I usually forget that. So I'm not like the Hawk system. More is better, right? So more accurate is better. But what did I say? The kind of a general rule for rounding means and standard deviations. One more than whatever's present in the original data. So you'd go to 3 decimal places because the original data is out to 2. But I'm not a real stickler on it. I don't like when you round way too much. If you round it to the nearest integer, obviously that doesn't tell me very much with data like this. So I'd probably count off some points for that. Okay, so without taking the time to do that, enter all the data, let's just get the answer. What is the mean, X bar? 1.462 out to 3 places. And the standard deviation will be labeled SX on your calculator. And what is it? 0.06 what? 6. Okay. And then the 5-number summary. They asked for that. So we need the min, 1.37. We need Q1, 1.41. And that, what's another name for Q1? Percentile. 25th percentile. Right? And then the median is also the 50th percentile is 1.44. Q3 is 1.51, and the max 1.59. Okay? Is everybody matching those? Alright, so let me put this up and then I can draw right on here. To draw a box plot, where does the box go? Which of these numbers form the box? Q1 and Q3. So the box goes between those. So 1.41, this is 1.4, 1, 2, 3, 4, 5. And so each of these must be 0.2 between them, right? 0.02 between them. So 141 would be halfway in between those tick marks. And then Q3 is 151, so halfway between those tick marks. And connect them. And then you draw a vertical line in the box at the median, which is 1.44, which would be halfway between those. Now this is going to make a shadow that makes it look like another line in there, but right? Now all that's left are the whiskers. The whiskers go out to 1.37. So this is 2, 4, 6. So 7 is right there. And 1.59 would be almost out here to 1.6. Okay? Describe the shape of the distribution. Slightly right skewed. It's not horrible, but a little bit of right skew to this. The median is off center, so the right side of the box is a little bigger, and the right whisker is a little bigger. Yeah, Randall.
Didn't you say the tick marks between 1.4 and 1.5 were 0.02?
This right, I don't know what I said, but this would be 1.42.
So why would it be with 1.44 be?
2, 4, and 4, 6. Yeah, you're right. It'd be right on that line, wouldn't it? Thank you. I was just seeing if you were, ooh, my shadow's the right spot. How about that? That's how I planned this picture.
And what are the odds?
You're a statistician. You figure it out.
Can you do the z-score on this one?
Okay, z-score. Is that part C? The z-score for the minimum value. So z-score is defined as the value, we call it x, placeholder, minus the mean divided by the standard deviation. Now I'm writing it out in words, instead of what I gave you last time was x minus mu over sigma, or x minus x bar over sx. Either one is fine. It's just the mean and the standard deviation. So we've got 1.37 for the min, that's our x, minus the mean, which we computed as 1.462, divided by the standard deviation, which is 0.066. So I need help with the math. What's that work out to be?
Negative 1.39.
Negative 1.39. Okay? Can z-scores be negative? Yeah. Negative means what? It's below the mean. Positives, it's above the mean. Right? Now, I have always harped on you that when you write down the answer to something, you take a second look at it and think, does that seem about right? Does that seem about, what does this number mean? I'm more interested in interpretation of what you just computed than computing it. Right? What does this number mean? Negative 1.39. Exactly. That means this value is 1.39 standard deviations below the mean. All right? Is that a lot or not so much? Yeah, it's not that much, right? To get way out there, you go at least to 2 standard deviations. And then if you're out to 3, then remember that's a tiny sliver of data left after 3. So in between 1 and 2 standard deviations isn't that far out there. All right, next question. Nobody has hit a probability problem yet. 30? Okay. Okay, number 30 says, let A be the event that a person lives in Atlanta, and let B be the event that a person works at the book factory. You see what I did there? A, Atlanta, B, book factory. Maybe you're not as impressed with that as I was. For the 2 events, A and B, the probability of A is 0.6, probability of B is 0.4, probability of B given A is 0.5. Find the probability of A given B. What? What is that? Say that in words. Probability of A given B. What does the A stand for? They work in Atlanta.
And
So the probability that they work in Atlanta,
and that they
not and, given that they work in the book factory. So think of me putting all the names of these workers in a hat, right? And I pull one out, and I say, well, I'm not going to tell you who I just drew, but I will tell you they work in the book factory. So once you know they work in the book factory, now what's the probability that they live in Atlanta, right? That's the way that question is worded. What kind of a probability question is it? What's your strategy for attacking it? Remember, I always say, well, you got to figure out how to organize your information, right? Well, this particular problem is what I call, this is a definition or a formula type probability. It's one of the rules, right? You need one of the rules and then figure out what pieces of it you've been given and where they fit in, right? Instead of, oh, I need to make a tree diagram or whatever, you could probably figure out how to do a tree diagram here, but it's not real obvious. So that's probably not the strategy. So since they're asking for a conditional probability, I'm going to go to my cheat sheet and I'm going to say, well, what is the definition of a conditional probability? It's the probability of A and B divided by the probability of the one you conditioned on. So B. Now I look up in the reading, did they give me those 2 pieces? No, they did not. They gave me the bottom one. They gave me probability of B. but they didn't give me this top. Hey, I just need another rule. What's the probability of A and B? What rule do you use to do an AND? Multiplication rule. So A and B is probability of A times probability of B, right? Isn't that the multiplication rule? Those of you that are nodding, I tricked you. This is the multiplication rule if what? But not always. If A and B are independent events, this will work. But this is a really common mistake on a problem like this. They just write this out as probability of A times probability of B. Oh look, the probability of B's cancel. The answer is probability of A. Well yeah, it works if A and B happen to be independent, but they're not here. How do you know they're not? You don't. So don't trust. Don't use one that only works if they're independent if you don't know if they're independent. Use the one that always works. What does this change to? Given A, right? So this, then I can replace in the top of that, probability of A times the probability of B given A over the probability of B. Now nothing cancels, but I have everything in the reading that I need. Probability of A, they tell me, is 0.6. So I'll put in 0.6. Probability of B given A, they tell me, is 0.5. And the probability of B is 0.4. Right? So you can multiply all that out on your calculator, and what you'll get is 0.3 over 0.4, which is 3/4, or 0.75. So if I reach into the hat and I pull out a slip of paper and say, well, I'm not going to tell you who this is, but they work in the book factory, now there's a 75% chance that they live in Atlanta. Right? Whereas only 60% total live in Atlanta. If they work in the book factory, 75% of them live in Atlanta. Not independent events. Okay, next question. 31, right below it. Suppose 4 marbles are to be randomly drawn without replacement from a jar of 26 marbles. If the 26 of the 26 marbles, 18 are red and the rest are blue. What is the probability that none of the marbles selected are red? Now, are there parts to this? Nope. Okay. Then I'll leave it there and just write down below. Okay, 4 marbles are randomly drawn without replacement. What does without replacement tell me about independence? The probability of a red marble is going to change from draw to draw. So they are not independent events. So when you use the multiplication rule, you have to use the conditioning. Right? So what is the probability that none of the marbles are red? Probability that none are red. R for red. Well, when I write it like that, I don't immediately see what formula I'm going to need to attack this with. But what does it mean to say none are red? It means they're all blue, which means I reach in, I pull out a blue one, and another blue one, and what word am I saying? And another blue one, right? So this is the same as the probability of 4 blue, which is the same as the probability of blue on the first one, times probability of blue on the second given blue on the first, times blue on the third times blue on the first and second times blue on the fourth. Boy, this is getting long. Given blue on the first, blue on the second, and blue on the third. Now, on a test, you probably wouldn't go ahead and string all this out with symbols. You'd go ahead and start using numbers. And that's okay. But you're ready now to fill in numbers. What's the probability of getting blue on the first draw? It says 26 total, 18 are red, the rest are blue, so how many are blue? 8. So 8 out of 26 on that first draw. Now on the next draw, you got a blue one on the first draw. So how many blues are left? 7 out of 25. And then you see the pattern. 6 out of 24, 5 out of 23, and there's your answer. When you multiply it all out, what do you get? 0.00 what? 468. Okay? So in other words, is this going to happen? Are you going to be able to draw 4 marbles without replacement and not get any red ones? Not very likely. You can try that 1,000 times. And only 5 out of the 1,000 will you get all red ones. It's possible, not very likely. But that's way more likely than you win the Powerball lottery. All right, next question. Any more questions? You're able to do all the rest of them? I'm impressed. Well, I can tell you this problem, there will definitely be one like this, where you are given a contingency table. It's possible that I would have you make the contingency table. There's one like that on here also. But then ask you probabilities about that table. So this is smokers, yes, no. So over here, it's hard to read this table the way it's set up, but this says smoke above this column. So this is smoke, no, yes. And then this is exercise, no, yes. You guys collected this data, although this is from a different semester. Got a different N here, but yours will be very similar. What's the probability that a randomly selected person from the table is a smoker? What numbers do I divide? How many non-smokers are in the table? 415. So you're using the marginal total of that row. Right? So this first one is 415 out of 505. And on the test, it's fine to leave it as a fraction like that. No need to reduce, no need to go to a decimal. You can. But on the test, another thing I want to say before I forget is that you need to show work. In the instructions on the test, it'll say, show work or you will not get any partial credit. If you write down the answer as a decimal for that problem, and it's right, great, you get full points. But if it's wrong, you miss all the points. But if you use like the addition rule and you're supposed to use the multiplication rule, and I can see that was your mistake, then you might get half the points. So, show your work. So part B, what is the probability a randomly selected person is either a non-smoker or an exerciser? What's the word or tell you to do? That's the addition rule. So probability of a non-smoker, NS for non-smoker, or exerciser, so E for exercise, that's probability of non-smoker plus probability of exercise minus, where do you subtract back off? That they're a non-smoker and they exercise, because the people that did both got double counted. So you subtract them back off once. So in the table, non-smokers we just did, that was 415 out of 505. Exercisers, there's a total of 247 exercisers. And then how many did both? That's in the body of the table. They had to be a no for smoke and a yes for exercise. 222 of them. So 222 over 505. And then add, just do the math and you got that answer. Probability of being a non-smoker given the exercise. Probability of non-smoker given the exercise. Well, it's a conditional probability, so you could use that rule that I had up there a while ago, but when it's in a contingency table, you don't really need to go to that trouble. Because conditioning on them being an exerciser tells me I only look at what part of that table. I only look at the exercise column, right? Because I'm conditioning on them. They have to be an exerciser to even be in this problem. So the exercisers are in this column. Now, of those 247 exercisers, how many were non-smokers? 222. So the answer is 222 over 247. Notice the denominator changes from 505, which is the total sample size. It changes. The only time it ever isn't the grand total in the table is when you're doing conditional probabilities. And then it becomes, the denominator becomes how many people met the condition. How many people were exercisers. Now this last one, about all I have time left, would you say that being a non-smoker and being an exerciser are independent events? Show why using probabilities. So I will not accept yes or no. I need to know why you think that, right, with probabilities. So I gave you a couple of different ways to check for independence using probabilities. Do you know what those were? One of them was to use that multiplication rule, see if it works, the version for independent events. If it works, then yeah, they're independent. But if it doesn't work, then they must be dependent. So that's probability of non-smoker exerciser. So do it once by looking at the table and figuring it out. To be both, we're 222 out of 505, right? So this is 222 out of 505. Now on the other side of the equals, and I'm putting a question mark above it, is that equal to probability of not smoking with the probability of exercising, or times the probability of exercising? This is how a multiplication rule works if they're independent. So if this works, they must be. So probability of non-smoking, we already did that one. That was 415 out of 505. Probability of exercising we did earlier. That's 247 out of 505. Multiply those together and see if you get the same decimal that you get on this side. And I guarantee you will not get the same decimal. And so the answer is, hey, it didn't work, therefore they must be dependent events. You could also check for independence by doing conditional probabilities. Is the probability of being a non-smoker given they exercise equal to the probability of being a non-smoker given they don't exercise? If they're independent, those should be the same numbers. But they won't be here. All right, well, good luck studying. Like I said, I will post the key this afternoon. So once you get the key and you look through all your answers, any that you still don't understand, make sure you email me. I'll be checking email all weekend long. Right? So good luck. See you Monday. Don't be late.